All right, so let's share a word of prayer and then begin. Father, we thank you for today's class and for a privilege to learn, another opportunity to study. We ask for understanding and clarity in Jesus' name. Amen. All right. So
Amen.
last week last 2 weeks, um we looked at the arrays. Okay, unfortunately, with that one too, I had a little challenge and the file or the video couldn't save. Um, all right, so we have two topics to go. I'm hoping that I can use this session to explain those two concepts. And then, God willing, next week, I'll make Eddie take you through some codes, some practical codes on the on these two topics. Okay, so today I'll try as much as possible to explain the theoretical concepts. Then next week, I'm sure next week will be more like a face-to-face meeting before the exams. Okay, so Eddie will take you through some practical codes. Yeah. All right. So um, let's look at methods. Okay, methods. So methods are the same as functions. Okay, the same as functions, just like we saw last semester. I think with the part-time class, I didn't go to that extent. Okay, but the full-time, I think we looked at functions as one of our last topic before the semester ended. Okay, so methods are the same as functions. Okay, and they are basically used, or they are uh, a unit or a block of statements that has a given name and it's used to solve a specific problem. Okay, used to solve a specific problem. Now, functions are very, or are one of the key components of every program, or methods. They are one of the key components of every program. Now, given a code, the method is more like the action part of your code, the functionalities behind the code. Okay, in other programming languages, they call it the procedure, okay, or the behavior of your program. Okay. Now, if you look over here, um, there's what we call the static, or there's a method here, okay, or a static method. Now, if you read, it says static method are units of procedural decomposition. So, typically break a class into several static methods for which solve some piece of problem of the overall problem. Okay, so if we look at the example here, this is a method to draw a box. A method to draw a box. Okay, let me see if I can just switch to the class if there's a drawing board, so I can just demonstrate something quickly. All right, can you all see my screen? The whiteboard.
No, sir. No, sir.
Oh, it's not visible. Is it visible now?
Yes, sir.
All right. Okay, that's great. So a method. So a method simply has it's made up of first a data type, a method first has is, can you see the text on the screen?
Yes, sir.
Okay. So a method
No,
first
sir.
has a data type. Okay. Now after the data type, there's the method name. Okay. Now the method name is followed by some parentheses or some brackets. Then we have you introduce your curly brackets, and then inside your curly brackets you have the various statements to perform the task. So maybe statement 1, statement 2, statement 3. Okay, various statements within your method. And then finally, you have what we call the return value. Okay, so the return value is always based on the data type. Okay. Now inside this bracket, we have what we call the arguments or parameters. Okay, so they are known as arguments. Make it wider. Arguments or parameters. So arguments or parameters are basically values that are passed into the method. Okay, they are values that are passed into the method. Okay, so first you have your data type, then the method name, then the method name can have arguments or no argument. There are times too where there are no arguments or parameters. Okay, no arguments or no parameters. Okay, then you have your statements, which are the statements going to perform the task, and then you have your return value. Okay, now the return value is always based on the data type that you use. Okay, so if your data type is an integer, you return an integer value. If your data type is double, you return a double value. Please, are we all following?
Yes, sir.
Yes, sir.
All right. Okay. Now there's a type known as void. Void. Okay. Anytime you use the void type, there is no return value. There is no return value. Okay. No return value. Take notes. So there are methods that will start with void. Anytime you see those methods starting with void, you don't, or anytime you use a method starting with void, you don't use or you don't introduce a return value. You have your statements all right, but there's no return value. Please, are we all here?
Yes, sir.
Yes, sir.
So that is the syntax, or what we have here is the syntax for writing methods. Okay, so now let's take an example quickly on what we have in the handout. So if you have your handout, you can see there's an example there which says a static method to draw a box. Okay, so typically you would have written the code and then you would have used your system.out.println to draw a box. Okay, but this time around you are coming up with a method. Now, one important feature of the method is that you can reuse it over and over again. Okay, it is the aspect of the code that is reusable. It's the aspect of the code that is reusable. Just a moment, please. Hello, babe. Yeah, I'm having some Zoom session here. Let me finish by 9 o'clock and call you back. Okay. All right. Thank you. All right. Can we continue?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Okay.
Yes, sir.
So the question is saying, or the example in the handout is saying that the method should have, or it's a static method to draw a box. Okay, so like I was saying, a box or the methods are reusable. Okay, anytime you have methods are reusable. Okay, that means when you create a method, you can use it over and over again in your program. Okay, now we want to come up with a method to draw a box. Okay, and let's say in drawing a box, we need some short dashes like this, a straight line like this, and then some short dashes like this. Okay, so this is the box. And how can we draw it? Okay, so to use the method, first we introduce the data type. Okay, now this box is made up of symbols. Are you all with me? It's made up of symbols, and with the symbols that we are going to output, these are like short dashes or hyphens. Okay, and then we have the bar. You can see it on your keyboard, usually close to the enter button. or I'm on top of the enter button. Okay, so these are symbols or keys that we want to use to draw. Okay, now they are not the typical data types that we know. Okay, these symbols here are not integers, they are not how do we call it, numbers. Okay, they are not letters. Okay, so because we want to demonstrate or come up with an image like this, okay, and we know that it doesn't fall under any of the data types we know or the basic data types we know, we use void. Okay, so once we use void, that means that this return value is out. Okay, then we come to the method name. Now the method name is any name we can represent our method by. Okay, the name that we can reuse anytime we want to draw a box. So I can give it a name, or we can give it a name, say draw box. Okay. So anytime you want to draw a box, you are writing a program and you want to draw a box. Once you have this method already existing, you can call it in the program and then it will draw your box. Okay, so we will name it draw box. Then we introduce what we call the open and close bracket, which is going to hold arguments. Okay, but in this case, with this example, there will be no argument, so we will just leave the brackets. We'll leave the brackets blank, but it's necessary we put the bracket there, even though there's no argument. So argument are values we will pass into it. In this case, we are not passing any value into the box, so we'll leave the brackets that way. Okay, then we introduce our curly bracket, which is going to contain our block of statement. Okay, so the block of statement, first we want to output. Hello, is someone asking a question? Okay, so our first statement will be to output this line. Our second statement will be this, output this, and then this will be our third statement. Please, are you all following?
Yes, sir.
Yes, sir.
Yes, sir.
So with the first statement, we introduce maybe a system.out.write line. So I'll use the S out, which I believe by now you all know what that gives us. So print line, and then within it, I'll just draw those short dashes. Okay, as a string, and then I terminate it. Then I come to the next line. So S out, system.out.print line. Okay, this time I introduce the bar, leave some space, and then introduce it again, and then terminate my code. And then finally, another S out again, dot print line. Then introduce what? My short dashes or hyphens as a string, and then terminate it. Okay, So what I've done here is that I've written, using the syntax, I've written a method. Okay, I've come up with a method to draw a box. Are we all here?
Yes, sir.
To draw a box.
Yes, sir.
Okay, so what I've done exists on its own. Exists on its own. Okay, now if you noticed, when we started writing our program, we did what we call the PSVM, right?
Yes, sir.
And what is the PSVM? Public.
Public static void main.
Yeah.
Void main.
Void main. Okay. Now that's the public there is what we call an access specifier. Okay, which we are going to look at that more in our next topic.
Hello, sir.
Hello.
Sir, I think one person has raised his hand. Jonathan.
Yes, Jonathan, if you have a question, you can go on and ask. Hello. All right, so let's continue.
Yeah. I think it's off.
Yeah, so let's go on. Let's go on. So we have
Okay,
this
sir.
public, which, like I said, we will talk about it more in the next topic. Then we have the static. So the static has to do with the fact that we are doing static methods. Okay. Then the void is a type which has no return value. Okay, just like we saw in the example above. And then we have the main. So the main, every program has a main method where the application runs. Okay, now you see that anytime we do the PSVM, it generates this method for us. Okay, then we go inside to write our code. Okay, now the method we have here, okay, or the main method always has to be in the program, or always has to be in your class. Okay, however, the new method that we have here, which we also call the user-defined method, because it's you, the user, that is actually defining or declaring this method, user-defined method. Okay, it is not written inside the main method. Please take note. Your user-defined method, so for instance, the method which is the drawbox method, you don't write it inside the void main. Okay, void main is a method on its own. That's the main method. Drawbox is a method on its own. Okay, so you don't write this code that we have on top here. You don't write it inside the class, the main method. Rather, you write both methods inside a class. Are you all following?
Yes.
Yeah, you put them in the class. Okay, and that is how you execute your method. Now, in order to activate or run this method, for instance, the drawbox method, in order to run it, you need to call it. You need to call the drawbox method you need to call it in the main class. Okay, you need to call it in the main class, and we'll look at that shortly in the handout. Okay, so take note, we don't put one method in another method. Rather, we call the methods inside the main method. You call it, and we look at how you call the method. Okay, we'll look at this shortly. So these are some basics you should take notes when it comes to methods. Okay, especially how to write the based on the syntax, how to write a method to solve a problem. Okay, so let me just take you through another example quickly, and then we can go back to our handouts. Look at the examples in our handouts. Okay. All right, so the earlier one, we wanted a method to draw a box. Okay. Now this time, let's look at a method to, for instance, let's say add two numbers, a method to perform, method to add two numbers. Okay, so if you are adding two numbers, what data type? Let's say the first number is A, should be represented by A, the second number should be represented by B. Okay, so A plus B should give you C. Are you all here?
Yes, sir.
Okay, so the first number is A, second number is B, and then that will give you C. Okay, or the result will be C. Okay, so how do you represent such a method in your program? Okay, that is to say that you are doing this in such a way that anytime you have any two numbers of any value and you want to perform some form of addition, all you have to do is to call the method, and then you set in your argument or your parameters. Then your method will perform the computation for you. Okay, so we said we want to add two numbers. So what data type do you think we can use here? One. Numbers, what data type?
Integer.
Okay.
Integer. Or long.
Okay, so
Now
let's use one. Let's say let's use double. Integer is a bit simple. Let's use double. So we are using the data type double. So that is to say that our return value should be a double value. Are you all with me? That means our return value should be a decimal value. Okay. Now we have to give our method a name. So we are adding two numbers. So always your method name should reflect what the method is doing. Okay, so for instance, in this example, I can say method name can be add numbers, or maybe add two. Add to num. Okay, add to num or add two numbers. Okay, whichever way you want to write it, so that anytime someone sees this method name, at least without seeing the statement in the method, the person will have an idea of what the method is doing. Are we all here?
Yes, sir.
Okay. Now,
Yes, sir.
this method, looking at the problem we have here, this method contains some arguments in the sense that, or parameters. That means that we want to add two numbers. Okay. There's parameters are the values that are passed into the methods or argument, values that are passed into the method. Now, looking at this, these values that are passed into the method are more of what we call the input values. Okay, they are the input values. So what do you think will be our input values from this problem? Anyone? What do you think will be our parameters?
Number A and B.
A and B, yes.
That's plus.
Okay, A and B. Okay, so now A, we have A and then we have B. So those are values that we need as inputs to perform our addition or to give us
they're
our
not
result, which
parameters.
is C. Okay, so if we have A, we have to give it a data type. Okay, and the data type mostly should follow, okay, usually based on the data type of your method. Okay, there are times where it can vary. Okay, but usually depends on the problem that is being solved. So you see here the value of A. Okay, I put the double A. That means I'm expecting a double value for A. And I also do double B for the integer. Sorry, for the value B. Okay. Now when we come to the statement, you can put a statement there like, or this is more of a straightforward something. Okay, this is more of a straightforward code. So I can come and say double C, because we've not declared C so far in the program. Okay, which is supposed to hold the variable that is going to hold our result. Okay, so we declare it's double C. Now we say C is now equal to A plus B. Okay, because the A plus B here would have been parameters which are going to be input values into your method. Okay, so we do A plus B giving us C, and then we will now return C. Okay, so the return value we see here, we said the return value should be the value of the data type of that method. So we return C, and C is a double value. The data type of our method is also double. So we return C. Okay. Are you all following?
Yes, I don't get it. Why return C? Because
We return the value of C. That is like we are saying that our answer is C. That's the last statement. Or the return here, we can say, if for instance we are using void, we can say system.out.print C. Do you get it?
okay.
Okay, but in this case, because we are using the data type, we have to return a value, and the value we are returning here is C, which is our result for A plus B. Okay, A plus B will give us C. So this is how we represent this example here in the form of a method, okay, by using the double double add name, add two numbers, and then the arguments being the A and B, and then we come into the method with statement double C. We add A and B to give us C, and then we return the value of C. Okay. Now,
Hello, sir.
Yes.
Hello, sir.
Yeah.
Please, can you go over? My network is actually disturbing a bit. I would like you to go over that place for me again.
Which place?
Where return C.
Yeah, so I said the return C, like we said, anytime your data type is void, like we know in the PSVM, you don't see a return value. Okay, just like you remember from last semester when we're doing C++, our main method was int main. Okay, so at the end of every code we write, you see we put the return 0. Do you remember?
Yes, please. I remember.
So that means that because of the int data type we had before the main, we have to return an integer value, which is 0.
Okay.
Okay. Now in Java, our main method is void, public static void main. So inside the main, you don't see a return value there. Okay.
Yeah.
However, what we are doing now is more of a user-defined data type. The task or the problem is given to you. Then you use your knowledge in writing methods to define or to come up with your method. Okay, so if you look at it carefully, the data type we used here is double. Kindly mute your microphone.
Yes, sir.
All right, so let's continue. So we are saying here that because the value is double, we return a double value. Okay, now here we are returning C. The C here, we declared it as double. Okay, and the C is our results after we've added A and B. So we return that result. Okay, then I also said that if we return C, it's just like we saying that system.out.println or display C. Okay, we are following.
I'm following.
All right. Okay. So that is how we write the method. Okay. Now the other thing we can do here is to call the method. Call the method. Okay. Now, how do you call the method? You call the method you call the method inside the main method. Okay, like I said earlier, you call it inside the main, inside the PSVM. Okay, so anytime you want to call a method, so let's assume we have our PSVM. So I'll just do PSVM for short. We have the bracket and then the curly bracket. Okay, so anytime I want to call this method in the code, I start by first introducing the method name. So the method name is add to num into brackets A and B, right? Into brackets A and B. So now that I'm calling the method, I'm going to now assign values to my A and B. So what is my value for A? Let's say value for A is 4. 4.0. We said it's double, so maybe I'll do 4.0. And then value for B is say 2.8. Are you following? So this
Hello, sir.
4.0 and the 2.8 are
Yes, sir.
Hello,
the values for A and B.
hello, sir.
Yes.
Please, I have a question.
Yes, go on with your question.
At your second statement, can you rewrite it, or when you rewrite it, you are going to get a different answer?
Rewriting it as in
A plus B equals C.
yes, you are going to get a different answer.
Wow.
Why are you
Okay,
saying
thank
so?
you.
Why? Write it yourself and see what you get. We have declared C, so we are saying that the value of A, take note, we have the left-hand side and we have the right-hand side. I think we learned something like this last semester when we were looking at operators. Okay, the left-hand side and the right-hand side. Okay, so the left-hand side usually is the one storing the computation or the expression or the operation taking place on the right hand side. Okay, so just because I've done it over here mathematically, this is how we would have done it. But if you are writing it in terms of a program, you write it this way.
Okay,
The
sir.
sort part comes first before this. Okay.
Thank you, sir.
All right, you're welcome. So we have our add to num, which is the method name, and then we have our parameters or our argument 4.0 and then 2.8. Okay, now what we've done here is that we've called the method. Okay, so this eventually, when we run the code, eventually will give us an answer of
6.8.
6.8. So that's more like 4.0 plus 2.8, which is 6.8. So it's going to return C, and our C is what? 6.8. Okay. So this method can be used over and over again. Why are we saying it can be used over again? We can call it another time in the program and say add to num, and then this time we can say 1.4 comma 2.0. Then that will give us an answer of 3.4, or it will return the value of 3.4 for us. Then we have maybe we want to add another number again. Okay, then we add it to the code again. So we'll call it again, we'll call the method again, add to, then num, then what are our parameters for A and B? Let's say 9.6, comma 1.4. Okay, and that should be giving us 11, I guess. Yeah. So we should be returning 11 for us. Okay, so that is how methods work in the program. Yes.
That's it. So, what of in a case where they ask you to add 4 numbers, but they've not given you one of the numbers to add?
Yes, so you are adding 4 numbers. So you just change your parameters, your parameters exactly. Okay, so 4 numbers. So let's say now you are doing A, B, C, and D. So increase your parameters to 4. You get it?
Okay.
Now it's a static something. It's not dynamic that it will change on its own. It's static. So it's you, the programmer, that has to make those changes to the code. Okay. So you just increase your parameters to 4. Then when you come into your code, the statement where it's performing the operation, the expression you have here, just do A plus B plus C plus D. Similarly, if the code changes to maybe write a method to maybe find the quotient of maybe two numbers, and we know that quotient has to do with what? Division, right? Okay.
Yeah.
That means two numbers, your variable A and B to represent the two numbers, or X and Y to represent the two numbers. Then C is equal to X divided by Y. Then you return your C. So the C you are returning becomes the quotient. Okay. All right. So let me just switch to the IntelliJ interface, and then let's try one example. Then we can go through the slide quickly and see if we can start chapter 8. All right, so let me stop sharing.
So, did you say chapter 8?
Yes.
Meaning we've done chapter 1, chapter 2, chapter 3, up to 8. Bro.
Are you asking?
Are you new to the class?
Yes, we are. Are you really asking this question?
Just new to the class.
Okay.
Last 2 weeks we did chapter 6 on arrays. It seems my brother is new to the class.
Yes, sir, it's new.
The earlier you start,
You're welcome.
the better for you.
Let's all welcome the newcomer.
You are welcome.
All right, so can we continue? Can you all see my screen?
Yes, sir.
So we have the IntelliJ. So this is the code from our last example we did, which is in your handouts on arrays. Okay. All right, so let's create a new project. I'm going to name this project. So let's say method 1. I'll name it method 1. I've shown you, we've talked about how to save your work in the folder and all that. Okay, so this is not the time to demonstrate that. So go into your SRC folder. First, you create your package. So the package, you say com dot maybe method 1. Okay, then inside the package, I create a class. So my class name, method 1. Now I've told you, don't separate the text when you are creating your class. Keep it together. Okay. All right, so let's look at the example of on the method where we use the adding two numbers. Okay. Now by default, we always have our PSVM. Okay, which is always a must. I hope you can all see that. So this is a PSVM, public static void main. but we are going to create or define another method. Okay, and that method is to add two numbers. Okay. And like I said, anytime you are defining a method or creating a new method, you don't do it inside the main method. The main method is only for calling other methods. Okay. So the method we did was what? Double add to num, right?
Yeah, add to num.
Okay. Then we gave it parameters, two parameters, double A, comma,
B.
double B.
B.
Okay. Then we introduce our curly bracket. So you can see from here that the syntax is more like what? The main method. Okay. Just like the main method. Like I said, we'll talk about why we use the public as we go ahead. Okay. So add two methods. All right. Now, anytime we have, you can see this red is here. It's here because we've used a double, we need to return a value. So if I introduce my return, you realize that that red is off. Okay. Now before that, we declared what? A variable double, declared double C. Okay. And then we said C is equal to A plus B. Okay. Then finally we do return C. Okay. So our method here is complete to add two numbers. Okay. Now we want to call this method. And like I said, anytime you are calling a method, it simply means that you are trying to what? Add, you are trying to execute the method that you've created. And how do you execute it? You execute it by now giving it values which form the parameters. Okay, so we say to call the method, we start with the method name. So I can just copy. Okay, so calling the method, start with the method name. Now it's expecting me to enter a value. Okay, so my first value, let's say 4.0
and 2.8
and then 2.8. Let me just add static here.
So where do you add the static over there?
Okay, so let's leave it like that, non-static. Okay. So you can see here that I've put 4.0 here. Now because I use what? Double A. You can see it's showing an A here. This A, I didn't type it. Can you all see that?
Yes, sir.
Okay. If I change it
Yes,
to X
sir.
and Y, you can see that what? It's changed to X. It's changed to what? Y. Okay. So these are values that I didn't type. Because I've already created the method, it's taking the shape of that method. Okay, so I can just now come and say system.out or sout after s, sorry.
Yes, sir. We didn't assign the add name to a variable in order to record the value.
Okay, yeah, that also is something we can do. So maybe
We can copy all and then paste it inside the system. Out print ln.
Print it, yeah. That also is also there. Okay. So over here, so we can, just to make it easy, we can say double. Sorry. Double. Let's say double add or double sum. Okay. And then we say sum is equal to this. So here we come and call let's say the sum of two numbers are so here we put our sum here.
Yes.
And then we have something like this. So now
Sir,
yes.
sir, please, the static has to come before double add two number.
Okay, I took this void out from here. PSVM. Okay. So thank you. So now we run the code. Okay. So it says the sum of our number is what? 6.8. So it's adding the two numbers 8.4.0 and 2.8. Okay. So we can call the method again. So let's say we have sum1 and then we have sum and then we have sum2. Okay. So this is the value for sum1. We have to perform some addition again. So we can say sum2 equals add two numbers. Now just take a look at this. Anytime I'm calling the method, okay, can you see this? Add two num double
it's not deep.
double y. Okay, so once I select it, it's expecting me to enter for double x. You can see it's there, double x. So if x is, let's say 1.4, comma, my y is say 9.6. Okay, then here I come and introduce sum1 and then maybe I copy and paste,
Okay.
and then do sum 2. Okay. Now when I run the code, it says what? The sum of two numbers is 6.8. The sum of two numbers are
11.0.
0. Okay, so you can see that we are reusing this code, this method we've done here for adding two numbers. Okay, we are using it multiple times in our code. Okay, so that is how methods work. They are reusable in your program. Okay. All right, so let's go back to the slides. So I explained some few things. Now that you understand the concept of methods, I'll explain some few things in the slides. Yeah. Any question?
Hello, sir.
Yeah.
Hello, sir.
Yes, go on with your question.
I said at the public static void, no. Sum 2 or 2. I don't understand that side though.
Which one is the
Are
sum?
you talking about sum 2?
The sum 2, where the S is 1.4, the Y is 9.6.
All that we are saying is that methods are reusable. Okay, so we've created one method, which is this, to add two numbers, and we are saying that you can repeat it multiple times by just changing the parameters. So sum 1 is the first time we've called the method. The method name is add two numbers, and then we've given it parameters, okay, or arguments. Then we repeat it again. We are calling it again. You are reusing this method again and giving it different values. That's basically what we are saying. So you can do it 100 times and be changing the value. It's a method, or it's a function for adding two numbers. So anytime you want to add two numbers, whichever number, you just have to call it like we've done here. And to keep adding the numbers for you.
The function is adding two numbers. What of subtraction? Let's say just doing division.
You can,
because I think C++ we had a function which was division, addition and subtraction.
yes.
So can you use the same approach?
Exactly. You can use the same approach. So if you remember, someone asked a question earlier about what if you have four numbers? And I said four numbers, you increase your parameters. Okay. So if you are using, if the problem is saying to find the quotient, then that means you are doing division, x divided by y. If it says find the difference, we are doing x minus y. Okay, when it comes to the aspect where you perform the operation. Okay. Yes, is it Nana Kwame?
Sir,
Yeah.
sir, from the code here, it's just like before the method key, That's the public static void main as the main method that we know that when we are starting with Java, writing anything in the IntelliJ, we start with PSD. So we first created the method which is a public class method 1. So anytime you want to bring in a method, will the question state it for you that use so that you are going to bring in method before coming to the main method and then reusing the method that you stated first. I don't know if you understand what I want.
So your question is that, so we want to introduce a method, okay, which is the add two numbers. So your question is, do we have to bring it first before the main method? Is that what you are trying to say?
Okay, so that one is also there. So is it good to do that for the first one before I go back to my question again?
Yes. Interesting. That's what you do. Now go back to your question and let's understand.
Okay, so you need to bring this method first before coming to the public static main method and then reusing the first method you stated.
Yes, you can bring it first, or you can even bring it after the public static void main. The important thing is that they should all be in the class. The method should be within the class. Our next topic in chapter 8 will explain it in details.
Okay. So this should be in a uniform line, or
let's finish with Nana Kwame's question. I think he has a couple of questions. Yeah.
Okay, sir.
So, sir, after you've done this one, meaning the method that you call for the first one shouldn't be part of the main method, but should be in the same class. And if this thing happens,
anytime you are writing a method, okay, your method should be written inside a class. So you can see the class here. Okay, let me just go up. You can see the class here. And this is the brackets, closing bracket for the class. You can see it's highlighted here. Now your method should be inside the class. However, you can't have a method in a method. So we can't put this static double add two numbers inside our main method. The only way we can have this method add two numbers inside our main method is what we call calling the add two numbers inside the main method, which is what we've done here. But we can't carry this entire code and come and put it inside the main method.
Yeah.
Do you get it?
Yes.
Like I'm saying, the next topic, which is on object-oriented programming, classes and objects, explains this better. Okay.
So as a programmer, when who's that now? I don't understand. Say as a programmer, can you call the method anytime you want, or there are certain questions that will let you call the method, or if you understand that when I call method here, it's going to work, that is why you call a method.
All right, so let me just use this scenario to explain it. Just like you said, you're a programmer. You've been contracted as a team to develop an application, a banking application. Okay. And if we take a bank setting, please mute your microphone. So if we take a bank setting, the basic things that the banks do, you can make deposits, you can create an account, you can make withdrawal, and then maybe you can invest. Okay, so let's say these are the four main things the banks do. Okay, let's take this as the basic. Okay, so these are like functionalities of every default or or banks in general. Opening an account, making deposits, making withdrawal, and then maybe investment. Okay, now these are functionalities, just like I said. So if you are writing an application for them, these four things that I mentioned should be four different methods that you are creating in your program. So one method will be for creating accounts, one method will be for making withdrawal, one method will be for making deposit, another method will be for making investment. Okay, now when you come into your main method, depending on what the person came to the bank to do, are you listening?
Yes, yes.
Okay, let's say you, Nana Kwame, you came to the bank that very day and you came to make a deposit some amount, okay, maybe 200 Ghana cedis. That means that as a programmer, you are going to write the program to call the deposit method inside the main and then assign that 200 Ghana cedis that you are depositing as an argument or a parameter to the deposit method. Then that will be added to or deposited in your or added to your current balance. Do you get the logic?
Okay.
So maybe you want to perform maybe 3 operations. You want to create an account, you want to make a deposit, and then you want to make an investment from the amount you deposited. You get it? So someone can come to the bank and perform those 3 functions at the same time, or those 3 methods at the same time. So when you come into your main method, you call those 3 methods inside your main method. That is where the functional or the behavior of the method will be executed in your program. I hope that analogy explains it.
So it's going small now.
Yeah, thank God.
Thank you.
It has to go, whether you like it or not. All right, so let me go back to the handouts and then quickly we skim through the handouts. I was hoping we can start the last chapter today, but let's see how it goes. I don't intend this class for us to spend more than 1 hour 30 minutes. So let me just go through the handout quickly on parameters. And it's now that you have an idea all right, so I've talked about this already, the public static void main method call, okay, which I've explained. So there's an example here. So draw 2 box figures using a static method. So you can see here the class name is box. Okay, now within that class there are 2 methods. We have the static void main, which is our main method, and we have the static void draw box. Okay, so the draw box method has no argument and it doesn't also have a return value. And then you can see that it's using system.out throughout the code. to draw the box. Okay, now when we come to the main method, this even answers your question, Nana Kwame. So you don't, it's not like you should, it's mandatory that the method you are defining should always come before your main method. It can come after the main method. Okay, so in this case, you can see that it's appearing after the main method. However, we are calling the drawbox method inside the main method. Okay, so this is the flow of that particular program. Okay, so inside the main static void.main, public static void main, you can see that we had the drawbox method being called here, then a system.out.print, then another drawbox method. This system.out.print is just to give a space between the two boxes we are drawing. It said you should draw two box figures. So this first statement, or this first drawbox that we are calling here, will draw a box using this method here. Then the second one will draw the same box again using this method here, and that's what has been illustrated here. So you can see the first drawbox method which is being called, and it's implementing the drawbox method. Okay, then system.out, then you call it again, then it repeats that method again to draw the second box. Okay, and this is the output as we can see here. Okay, all right, so go and try out this and give me a comment on what you were able to do. Is the full bar bars marble. Okay, so you are calling a method inside another method. Okay, call methods that call other methods. Okay, so it's not only in the main method that you can call other methods, but you can call them in other methods. That's what this example is suggesting. Okay, so read on it. Then we talked about parameters. There are two main types of parameters or parameterization. It says parameterization is a set of characters that distinguish different members of a family of tags. Okay, so it's used to identify a set of parameters. So there are two forms of parameters. There's the formal parameter and the actual parameter. Okay, so the formal parameter is what we did in our code when we said double x, double y. They are called formal parameters. Now, when we came into the main method, the function call, that's where we implemented the actual parameters. So for the value of x, we put there 4.0. The value of y, we put there 2.8. Okay, so that's the difference between the formal parameters and the actual parameters. Okay. Okay, so this example also on parameterization, just to explain the formal and then the actual parameters. Then we have multiple parameters, so you can have multiple parameters. So the question someone asked about adding 4 numbers. In fact, 2 numbers even qualifies for a multiple parameter once it's more than 1. Then the 4 parameters also having multiple parameters in your static method. Okay. Then we have method overloading. Method overloading is the ability to define 2 or more different methods with the same name but different method signatures. Okay, method signature is the name of a method along with its number and the type of parameter. Okay, so method overloading simply means that you are redefining, okay, or adding some specifications to a method. Now, there are two main types of method. I think I didn't really talk about that when we started. So there's the inbuilt or the predefined method, and then there's the user-defined method. Okay, so the inbuilt or the predefined methods are methods that already exist in your Java program. Okay, if you remember last semester in C++, I gave you some question that you should go and look for the various methods, libraries in C++, and for each library you should state, is it 5 or 10 methods within that library?
yes, sir.
Okay, the same applies here. Okay, so for instance, if you have mathematical, there's a mathematical package or library which has inbuilt or predefined mathematical methods that you can use. So if you are writing a program and there's something to do with square roots or power and so on, those inbuilt or predefined methods are there for you to use in your program. Okay, so the same way we did for C++, please do the same and try and find out some of these inbuilt or predefined functions in Java as well. Okay. Can we go through this so that next week Eddie will take you through the examples? Let me introduce you to OOP. Then next week's face-to-face, Eddie will try examples with you. So let's use some 15 minutes to explain this. Hopefully by 9:45 we should be ending the class. Okay. All right, so the concept of object-oriented programming. Okay, now our course this semester is centered on object-oriented programming. Are you all with me?
Yes, sir.
Yes, sir.
So our course is centered on object-oriented programming. Okay. Now, Java, C++ are all examples of object-oriented programming. Java, C++, Python are all examples of object-oriented programming. Now, it says here, object-oriented programming means reasoning about a program as a set of objects rather than a set of actions. Okay. Now, object-oriented programming is trying to say that anytime you are writing a program, just picture whatever task or whatever problem you are solving as a form or as an object. Okay, picture it as an object. Now, if something is being pictured or considered as an object, or reasoning about a program as an object, then there are two things that every object has. Every object has an attribute and a behavior. Okay, every object has an attribute and a behavior. Okay. Every object has an attribute and a behavior. So basically, that's what object-oriented programming is about. So you should reason about every program as an object. See it as an object. You want to write a program to develop a bank application. See that bank application as an object. and divide it into two. It should have two attributes. It should have two parts. There should be an attribute part and a behavior part. Okay. If you take a human being is considered as an object. Human being would have two parts, the attribute part and the behavior part. Anything at all that you want to write a program about, just consider it as an object, meaning that it has two parts, or it can be broken down into two: the object, the attribute part, and then the behavior part. Okay, so this semester I decided to add these images to your handout to make it for you to appreciate it. Unfortunately, the printout was bad. Okay, so I think I came up with I've decided to make those images as PDF to send to you. Okay, so class rep, please remind me to do that before the close of the week. Okay, because most of those handouts, the images were not clearly printed. Okay. All right. So OOP simply starts from object-oriented programming, and it's a programming paradigm that revolves around the concept of objects, and it brings into software development what we call modularity, reusability, and maintainability. Okay, these are this concept is used mainly in software development. Okay, now the object-oriented programming stands on 4 pillars. The first pillar is called inheritance. Then we have polymorphism, we have abstraction, and then we have encapsulation. Okay, so I'll use the images in the handout to explain the concept so that you have an idea of what they all do. Okay, so first we start with classes. Now you notice that anytime we are writing our Java program, after creating the project, the next thing we do is to create a class. Okay, we create a project, create a class, and then we create a class. Now, what is a class? A class is simply a blueprint, okay, or a template that defines the attributes and behavior that an object of that class will have. Okay, so if we say something is a blueprint, it means that or it's a template, it's been designed for you to follow. Okay, just like we have buildings, just like we have before someone comes up with a building, okay, they come up with a plan, a blueprint of the building, or they are going to construct a bridge, okay, or some artifact or something. There's always a blueprint, okay, for people to appreciate how the real building or the real construction is going to look like or take shape. Okay, so these blueprints or templates are based on attributes and behavior. Oh, my brother, why do you keep on muting yourself? What's the name? In Glitam or what? Also, I'll take you off the call. Michael.
Yes, sir. It's a mistake.
Yes, please. You keep distracting the class. Okay, let's continue. So, yeah. So the blueprints always has these properties. We have the attributes and behaviors. Okay. Now, anytime we mention attributes, The attributes can also be seen as the property, can be seen as the data variable, okay, of your class. Then the behaviors are the methods or the functions or the operations, okay, within your code. Now, personally, I try to differentiate these two aspects of your class, of the class, as the attributes being more like the noun, okay, and then the behavior being more like the verb. Okay, so the behavior is more like the action part of the object or your class. Okay, so for instance, if you take a human being as a class, the human being has attributes or data variable attributes. So for instance, the height of the human being, the weight, the color of the eye, the complexion of the person, okay, the shape of the head, and so on. All these are attributes, things that uniquely define the human being. Okay. Then we have the methods or the behaviors, the action part of the human being. Okay. So a human being can walk around, kick, eat, sleep. Those are like action related things. So we call that the behavior. Okay. So every class would have this attribute. For instance, if it's a bank application, okay, so the class is a bank application. What are the attributes? The attributes can be the account name, the account number, the address of the account holder. Those are attributes, things that uniquely identify the person who holds that account.
The signature.
Yeah. Okay, or thumbprints. Okay. Then we have the methods. Methods are, or the behavior. Okay, so like the example I gave earlier to Nana Kwame's question. So methods, a bank application, what are the functionalities? What are the methods of the application? What are the behavior of a bank application? You can withdraw, you can make deposits, make investments, get loan, and so many other functionalities. I hope
Pensions.
Okay, so basically that's how you picture any problem you want to solve in the context of object-oriented programming. Are we all here? Okay, so someone wants to develop an application for maybe a school, maybe a preparatory school or a high school somewhere. Okay, so you look out for what are my attributes, what are the things about the application I have to consider as attributes, what are the things I have to consider as methods or as behaviors in my application. And all that will fall within what we call the class. Okay, now let's talk about an object. An object is an instance of a class. Okay, instance or an example of a class. Okay, so it represents a specific entity with its own unique, take note of this, it has its own unique attributes and behaviors. Okay, even though the class is more like a more generic attributes and behaviors. Okay, but the object is a more unique, a more yes, I think the best word here, has its own unique, a more specific details of that class. Okay, so for instance, if we take a human being as a class, okay, if we take a human being as a class, maybe Marvin will be an object of that class human being. Okay, so if Marvin is an object of that class human being, it means Marvin is a specific entity and Marvin has his own unique attributes. Okay, generally, the attributes of a human being will be the height, the weight, maybe the complexion. But if we take Marvin as an object of the class human being, then Marvin will have his own unique attributes in terms of the height. So the Marvin's height can be maybe 5.8 inches, or sorry, 5.8 5 feet 8 inches tall. Okay, Marvin's weight can be maybe 78. Marvin's complexion can be light skin. So those are unique or specific entities for the object Marvin. Okay, then Marvin's maybe methods or behavior would also be unique. Okay, kicking or kicking the ball. How does Marvin kick the ball? Maybe he kicks the ball more with his left leg rather than the right. Okay, or writing. Writing can be a behavior. Marvin is left-handed. So that is a unique behavior of Martin. Are you following the discussion?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
All right. So let's take, for instance, the concept of the bank application. Okay. So the bank application can be the class in general. So that is to say that if you are saying the class is the bank application, that means every bank, let's say in Ghana, every bank in Ghana will follow that blueprint or that class bank. Now the object here can be a specific bank. Okay, so let's say EcoBank. So the object here can be EcoBank. Are you with me? Okay. The objects can be EcoBank. Okay. Another object can be maybe Absa Bank. Another object can be GCB. Okay. So those are objects, instances of the class bank. That means that when we define the class bank had a generic or a general attributes and behaviors. For every bank you go to, there should be, every individual or business should have an account name, account number, signatories on that account. It should have what do we call it, address, and maybe the branch. Okay, and this is the same across all banks, so it is more like a template. All these banks have behaviors like performing investment, deposit, withdrawal, okay, and so on. Okay, and these are behaviors. Now, when you come to the objects, so let's take EcoBank, for instance, as an object of the class banks. Okay, EcoBank will have its own unique attributes and behaviors. Okay, so if we take, let's say, EcoBank, if let's say NSC Yeboah goes to EcoBank to open an account, EcoBank will have its own unique way of taking an Esieboa's name or account name. It will give an Esieboa a unique account number, which will be different from maybe Maxwell or Linda Miles going to maybe Absa Bank to open an account. Okay, even though the attributes are the same, both account number, account name, okay, however, the values of those attributes are unique to a specific object. Okay, so that is what happens. Similarly, when we come to the behavior or the methods, okay, let's say you want to perform an investment. The methods, or both banks are classes, okay, both banks fall under the class bank, okay, so they would have the method of performing maybe investment, okay, or doing an investment. Now, what will happen is that if maybe NS goes to his EcoBank has its unique way of performing an investment. For instance, in their method, they might have a rate or an interest rate of maybe 13.5. Okay, when Linda goes to let's say Absa, even though it's the same method of investment, Absa also have their unique rates of performing investments. Are you following the concept? Okay, so that is basically what object-oriented programming is about. Okay, understanding the concept of classes and objects. Okay, I'd want you to go and read further on it works more in software development. We call it the UML class diagram. Okay, UML class diagram, Unified Modeling Language class diagram. Okay, it's just a concept that every programmer, every software developer needs to appreciate. Even these are things you do way before you develop your application. And these are things that you'll be looking out for in your final year project work, where you are developing something and you need to come up with a class diagram. Okay, these are my attributes, these are my methods I'll be using in the code to develop so and so application. Okay, all right, so let me just talk about a few things. I think when you meet Eddie next week for the practical, you get more, understand it more. And it doesn't end there. Like we said, there's Java 2. Okay, so Java 2 will go over some of these things again, especially the classes and objects with more complex examples for you to appreciate. Okay. All right, so let me just talk about the pillars quickly. So one of the first pillar of object-oriented programming is encapsulation. Encapsulation simply means that you are binding data together into a single unit. Okay, now this example here explains it or makes it very easy to understand. So for instance, sorry, I'm using footballers or example of football. Okay. But I believe it's something that everyone can appreciate. Okay. So encapsulation simply means that you are hiding some implementation details of the object from the client. Okay, so we are binding data together into a single unit. So in football, what happens is that the coaches develop the tactics and strategies and they hide it from their opponent. Okay, so as a programmer, you are hiding those complexities from the user. Let me put it that way. Okay, then there's some form of collaboration as well among the users. Among the, in this case, among the footballers. Okay, and some individual abilities and things are being hidden, okay, from the opponent. Okay, so that's how encapsulation works, but all this happen within a single unit. Okay, then there's abstraction. Usually there's people misconstrue the concept of encapsulation and that of abstraction. Okay, so abstraction has to do with the user seeing only the essential parts. The non-essential parts are hidden, okay, or they hide the non-essential details. Typical example is we watch football match movies on phones, laptops, TVs. Okay. The essential parts as to what goes into the technology behind the things you see on your phone and all that, how the video was shot, the camera angle that was used, the communication taking place between the director and things like happening behind the scene and how even that video came out for you to watch. It's non-essential to you as a user. All you want is you subscribe to or you turn on your television and you are watching your movie or your football game. Okay, so those details are hidden. The non-essential ones are hidden from you. Okay, and the essential ones are just given out for you to appreciate. That's the concept of abstractions. Okay, and then we have the other two concepts, inheritance. So let me just go through that quickly. So inheritance means you allow other classes to inherit common properties from parent classes. Okay, so maybe there's a class, which has attributes, okay, and some properties, and then there's a child class. So there's a main class, which is the parent class or the base class, and there's a child class which is inheriting some properties. Okay, so this concept works just like we know of inheritance in families, where maybe you inherit some traits from your dad or your mom, your parents. Okay, maybe the way you talk. Okay, it's not like you inherit everything, but there are some traits that you can see that this lady is the daughter of so and so because of the way the person speak or the person's mannerism and so on. Okay, so that concept also works in programming, where you don't necessarily have to, you are introducing a new class. you don't necessarily have to repeat all the codes within, or you don't necessarily have to recreate the code for the class again. You can inherit from a class that already exists. Okay, a typical example, let me just give you an example. So for instance, you are creating an application, let's say for let's say a bank. Okay, so you've created a class for a bank, and then the same application, you want to create something for a savings and loans aspect. Okay, so a class bank, then a class savings and loans. Now I can tell that a savings and loan company are actually getting their functionalities and attributes that they will use just from the concept of a bank, just that they are operating at a lower level. Okay, so instead of creating the savings and loan, writing the program to declare a lot of objects and declare a lot of attributes and methods for the savings and loans, once it's in the same program, just go and make the savings and loan class inherit properties like account name, account number, address, and some properties from the bank class without you having to write the whole program again for the savings and loan. Okay, so that's the concept of inheritance in that aspect. Okay, and then finally we have polymorphism. So polymorphism is the ability for a particular program to exist in many forms. Okay, so if you look at the example here, it's taking a footballer, okay, who has can play in different positions. So the same footballer is a striker or attacker, is a midfielder, can play the midfield position. The same person is a captain of the team. Okay, so just one person playing different position. Okay, or showcasing different or multiple forms of action within the code. Okay, so all that has been explained in details with some examples here. Okay, so hopefully next week Eddie will take you through more examples, and then also I don't know when you are writing this paper. Pardon? Okay, so next week we will look at some areas on which to prepare on towards the exams, and Eddie will take you through some codes as well. Even when it comes to the areas, I've already mentioned it already. So during the face-to-face
No, sir.
sessions, if you are attentive in class, you have an idea of some of the things I was emphasizing on. Okay, so but by next week, by the time we meet for our last session, Eddie will take you through all of them in preparation towards the exams. Any question before we end the class?